There it goes. All right, so this is a little bit of review of what we've been doing. So we want to make sure we break down the math operations with the radicals. So, friends, talk to me. 32 breaks down to what perfect square?
16 and 2.
16 and 2. Now, some of you might think, hey, should I do 4 and 8? You could. 4 is a perfect square. 8 also has a perfect square. But if you realize 16 is the largest perfect square that goes into it, square root of 16 should be 4, so we just come up with an answer of 4 square root 2. Agree? Then the second problem, we want exponents to be even numbers when we take the square root, because we take half of it, right?
Yeah, you can just x squared out.
Okay, so I'm going to do 4 and 2, right?
Yeah.
And then x to the 4th times x. And then, how should I break y up?
Y times 5y, 4y.
4, there you go. Y to the 4th times y. Cool. All right, so friends, perfect square. What's the square root of 4?
4.
Yeah. Question.
What would be 3x times? Yeah, they shouldn't be 2x's. Yeah.
Oh, holy cow. Who came in the door? Nobody. All right, see, no mistake anymore. Oh, wait, it's recorded. You are so right. Thank you so much for making that correction. So what's the square root of 4?
2.
2. Square root of x to the 4th, thank you for the correction. X squared is just half of it. Square root of y to the 4th?
Y squared.
Y squared. And then I have left behind a 2 and a
Y.
There we go. Thank you for making that correction for me. I made a mistake. All right, square root 3 is not going to break down, but let's see. X to the 4th times y, is that right? Oh, times x, I'm sorry, x to the 1st. Times
y to the 2nd, y squared times y.
There it is. So 3 is not a perfect square. Square root of x squared, or x to the 4th is x squared. Square root of y to the 2nd is just y. And then I have kind of a lot left behind. I have the 3, x, and y. Is it okay if I put x to the 1st and y to the 1st? Sure. Your choice. If you want to waste the lead and the pen on it, bless you. Bless you again. Bless you again. All right, so that's old stuff, yes? That's what we've been doing, correct? All right, so now we've dealt with this as well. This is kind of, so I could multiply 6 times 8, but I think kind of the better thing to do is break the 6 down to this, break the 8 down to this. Is that okay? How many x's are we talking about? How many x's would be underneath the radical? Go ahead, Philip. It'd be x to the 7th, which is going to break down to x squared, or x to the 6th times x to the 1st. Love it. Hey, how many y's are downstairs? How much? 4. 4. And that's a perfect square, right?
Yeah. Just take y squared out.
There you go. All right, so I am looking for pairs. So
yeah, 2 pairs of 2.
2 pairs of 2, and 2 pairs of 2 means I'm multiplying 2 times 2 outside, which is?
4.
Everyone agree? Excuse me.
And then you can also take the 3x, 3 cubed.
X to the 3rd, okay. And?
Y squared.
Y squared. What's left behind?
X.
X
3.
and a 3. Anything else?
No.
X and 3. Sweet. Okay. So that was like totally last week's stuff. Agree? Anybody have questions on any of that? Am I losing anybody? Now, friends, am I putting more work up there than some of you might need? Yeah. Is it okay that you kind of do a little bit in your head? Sure. But just make sure, if you're doing a little bit in your head, make sure your answer is being correct, because you might be messing something up. Or you could be like me and just start making things up, which that happens. All right, so we're now going to do adding and subtracting with radicals. This is, you teach treat a radical the same way you would treat like a letter. Okay, so excuse me. First thing I can do.
It's not root multiplying that other
Oops.
radical.
So we're just adding or subtracting. So, friends, root 3 and root 3 are the exact same thing. Agreed? Wait 1 sec.
Is that 7 a part of the root?
Yeah, it's 7 times square root 3.
Oh.
Okay? So, being these are the same, and we are going to subtract. I'm going to go 2 subtract 7, and that's going to give me -5. And then the root 3 comes along. So radicals do not increase or decrease when we add or subtract. The numbers out in front of them do, but we treat the radical just like an x, okay? Okay, so friends, do you all agree that these are different radicals?
Yeah.
Everyone feel comfortable with that? So right now, I cannot go 3 plus 7. I cannot do that right now because I have a root 18, and a root 18, at least this week, is different than root 50. Yeah, we're trying to do common denominators, but what we want is common radicals. I like that. So friends, would it make sense to break 18 down to 9 times 2?
Yeah.
What's special about 9? Go ahead. Yeah. So, what about 50? What does that break down to?
5 times 5 times 2.
5 times 5 times 2, or 25 times 2, agreed? Right? So, our perfect squares are a 9 and a 25. Those are both perfect squares. Okay? So, on the first one, I have the original 3 times the square root of 9, which is 3, and then I have a square root of 2. That'll give me 9 root 2. And then the second one, I have 7 times square root of 25 is 5. And then I have a square root of 2, which gives me 35 root 2. Okay. Are my radicals the same now? Yeah, so I can go ahead and combine them. So it's still going to have root 2 as is. And I'm going to go 9 add to 35. I think it's 44. So I get 44 root 2. And it's done. So take a look at that. There's quite a bit I did up there. I had to make sure my radicals became the same before I added or subtracted. So in this case, I was able to break 18 down as 9 and 2. And the reason I didn't do 3 and 6 is because 9 is the biggest perfect square. 25 and 2 makes 50. So it's square root of 25. So square root of 25 came there. Square root of 9 came there. And then we multiplied the outside stuff. And then once everything was all together, you can add 9 root 2 and 35 root 2. The root 2 stays the same. 9 plus 35, 44. So 44 root 2. Anything up there that's question marks? Are we okay? Can I move on? That's a good cup of coffee. I must have washed the coffee pot out or something this morning. All right, so friends, 5 square root 80 and subtract 4 square root 24. We all in compliance saying, hey, root 80 and root 24 are not the same radical? Yeah. Okay. So I want to make my radicals the same. So right now, this and this are different. So we need to make them the same. So the 5 comes down. How much?
40 and 2.
40 and 2. Okay. Hang on. We got the squares up there. Let's see. I'm going to start here. Well, 81 is not going to work. Well, 64. No, that's not going to work. Well, 49. Give me 80. No, well, 36 times something. Give me 80. No, well, 25 and something. Give me 80. Well, 16 and something. Give me 80.
Yeah.
Yeah. 16 times what?
5.
5. Great job. So And so the reason I did that is I'm looking for my biggest perfect square. So 5 times 16 is 80. Subtract 4. What's my biggest perfect square in? Yeah. Yeah, 6 and 4. Okay. All right. So square root of 16 is what?
4.
Somebody's got music on a little loud, Josh. I think it's Josh. So I get 5 times 4, root 5, minus 4 times 2, root 6. So that gives me 20 root 5 minus 8 root 6. Hey, friends, is root 5 and root 6 the same thing?
No.
No. So this is my final answer. So, hey, friends, I'm going to tell you, this, you don't realize this at this point yet, but all of the technology we use is going to utilize exact answers. So this is an exact answer. We did not take a decimal approximate and plug it in for root 5 and a decimal approximate for root 6. And it's the exact answer. Okay? The more and more exact answers that are happening on our internets and our phones and all the other things means the more and more precise it is to picking up the location. Have cell phones become better in even just the last 5 years? What do you think? Yeah, we went from like 4G to 5G. 5G, I don't know, is 5G better? I don't know. I've heard some people say, oh, it's great. And then I've heard the conspiracy theories going, it makes you go crazy, these 5G towers, let's light it on fire. It's like, what?
Mind control.
Yeah, mind control. I have no idea if it does or doesn't. I just like the fact when I go to use my phone, it works, right?
Yeah.
I really don't think the cell phone people are going, okay, got an idea. We're going to have this next generation. We're going
to have it control your mind so that we can
Yeah.
make you buy our phone.
We will make people sneeze on command. This is what we're going to do. I don't think so. But it's an exact answer. And again, my friends, the exact answers are what makes our items work better and better and better with the programs that make them run. So you really do want exact answers to take place, which, I mean, is your cell phone important to you? Well, it seems to be. A lot of you have yours out often. I see you guys walking down the hall going like this, looking at it, right? You have no idea if people are around you, and then you bump into the person in front of you because they're like, "Ooh, look, Sally on Instagram," right? That's okay. I mean, I'm just trying to point out things that I see. I guess I have to get on social media because I haven't been having fun with that. All right, my friends. 10 square root 2 as a quantity, meaning I have it in parentheses. When I say quantity, I have the whole thing squared. So this means I have 10 square root 2 times 10 square root 2. There's 2 of them because I had 2 of those. So 10 times 10 is 100. Root 2 times root 2 is root 4. Root 4 is what this week?
2.
2. So this came up with an answer of 200. Want a sip of coffee? It's good for you. We feeling okay? I think I give Dan the comfortable factor today. I have not seen a student that comfortable in a long time. The only thing missing is that little airplane pillow you could have behind his head.
Yeah.
Maybe I'll get like a line locker, the thing, open it up, and you put your stuff in there and take stuff out. I'm just giving you a hard time. All right. I have root 3 outside. Inside my parentheses, I have 4 minus 2 root 3. Okay. I think this is a distributive property problem. What do you think? So if I go 4 times root 3, do you feel comfortable saying 4 root 3? Okay. Minus root 3 times root 3 is root 9. What's root 9?
3.
3. So notice part of our answer lost its radical. That's okay. 4 root 6 subtract 6, exact answer. Sometimes you might see this answer like this. It doesn't bother me which one you did. I mean, it's just rearranging it. Some people like to see the whole number first, followed by the irrational number. Root 6 is called an irrational number because it's a decimal that never repeats, it never stops, it goes on forever. Yes?
How do you get the full 103 on the 400? How do you take my 4 with 3?
Oh, how I flipped it over?
No, I take my 4 with 3, 4 with 3.
I think I'm making math up. So there, that should be a root 3. And that should be a root 3. I'll tell you, you can't take this teacher anywhere. Boy, I just make mistakes all day long. I'm sorry. Y'all know that I give y'all, you get your grades, but then at the end of the year, you get to give me a grade, okay? So he missed, 17 things. He got an F minus minus. Yeah.
Going back on the 10 root 2,
Uh-huh.
why go 100 root 4 to 100?
Oh, that's a great question. Okay. This came here and here, so that gave me 10 times 10, which is the 100. Root 2 times root 2 gave me root 4. Root 4 gave me 2. And then I went 100 times 2 to get 200. Does that make sense? Sure. You don't have to ask. You just take care of that. Okay. This one's similar to what we've been working on. I have root 98, so I get on my perfect squares over here. So let's see. 100 times something doesn't give me 98. 81 times something doesn't give me 98. 64 times something doesn't give me 98. 49 times 2. So again, notice I'm referring to my perfect squares, and I know that I can break this down to 49 times 2. And again, 49 is a perfect square. I'm going to break x to the 5th down to x to the 4th times x to the 1st. And I'm going to break y to the 3rd down to y to the 2nd times y. Is that okay? Square root of 49 is 7. Square root of x to the 4th is x squared. Square root of y to the 2nd is root. I have a 2, an x, and a y that are left behind. They didn't break out of jail, did they? They didn't break out of the square root jail. How are we doing? We doing all right? Life is good? I got that. Okay. All right, friends. Let's see. Yes, I can. Yeah, buddy. Oh my gosh, don't you worry. Everyone else good? All right, hey, we're back to multiplying. Okay. 5 times 2 is going to give me the 10. But I'm going to break 21 up to 3 times 7. And I'm going to break 14 up to 2 times 7. So this is kind of what we've been doing. The 7's come out because 7 times 7 is 49. Square root of 49 is 7 this week. And then I have left behind 3 and 2. So outside I have 70 root 6. Problem done. So that's like so last week, dude. Almost done. What should we do when we get done? You guys want to play hide and seek or something? Have a rock fight outside, start throwing rocks at each other? Oh, that was the best. When we were kids, because we used to have the aluminum trash can bins, so you have a shield and throwing rocks at your friend and blocking them with a shield. And there's always inevitable someone gets hit in the head and they're crying. And then you move the game elsewhere so their mom doesn't come out and yell at you. Why'd you make Duke cry? I'm not, it wasn't me. Oh, what happened? He threw the rock at himself.
It's his fault for not talking.
I don't know how my generation of friends made it as far as we have, but it's still fun. All right, 2 times 4. I got an 8 outside. I got a 3. Break down that. 3 times 2. I love it. And then x squared and y squared. Does everyone agree with the math that we did? X times x, x squared. Y times y, y squared. 3 times 3 times 2 is the same thing as having the 3 and the 6 times 2 broken down. All right.
You can take that x, y, and 3 out.
Yeah, those are all my perfect squares. What's the square root of 3, 3?
9 and 3. And x, y.
What's left behind?
2.
Just a 2. 3 times 8 is 24. Root 2. Hey, somebody asked the other day, is this answer and is this answer the same?
Yeah.
Yeah. When you have things that are all pushed together, that just means they're being multiplied together. You're going to show me that you don't know how to do math by having 24 times x times y times root 2? No, that's the same answer. I'll take either. All right. Hey, what's the square root of 49?
7.
What's the square root of 6? Or 36? 6? Where's the square root? Well, I was able to apply the operation. It's done. Okay. So, yeah, the square root goes away. So, let's kind of sum up some of the ideas. So, like roots can be added or subtracted where the outside number is all that we add or subtract. Keep radical the same. Okay, that's what we just started working on, right? So that's an idea. If we have a quantity squared, that means, so if we had a quantity, a smiley face squared, that means we have smiley face times smiley face. Okay? What's smiley face? I don't know. I'm just kind of making stuff up. And then all the stuff from last week. It's all there. We got it all. All right, so friends. Hey, I have a question. We got an email, and I don't know if this is us or not. We got an email from the principal saying, quit giving so much homework.
Yeah.
Have I increased?
Yeah. Slightly. Yeah.
Dan, I haven't increased.
I mean, like, technically, we're not like. Yeah. It's not that much, but it's the same.
I had a total of 3 lessons last week.
Yeah, that's a lot.
Okay, hang on. So we had a remote day, which was a lesson. I had a Tuesday, Wednesday, or Tuesday, Thursday, or Wednesday, Friday. We did 3, and we actually didn't do 3. We did 2, and a review, and a quiz. That is no more than what we've been doing. So y'all shouldn't be emailing the principal saying Sturp's giving too much. You should probably email the principal saying Mr. Sturp's not giving enough. Well, that's world language. We're math people here. Those darn people. So Dan's gonna say I give too much no matter what.
Yeah.
But am I giving okay? Is anyone like crying themselves to sleep? You are? Okay. It's not because of me? Okay. Josh, you're crying yourself to sleep again?
Sometimes we're not.
I love it. All right. So, my friends, we are going to do
50 pages.
no. Solving quadratic equations. Yeah. What? Okay. Then you have the rest of the period to work on it.
Are we allowed to get our quizzes back after everyone's done with them?
I normally don't hand them back. You're welcome to come by and look at it anytime.
I just want to see if I got the extra credit problem wrong.
All right, so we have a little bit of time. So does anyone need a picture of this page? If so, come on up and take a picture of it.